Maybe the next thing that I want to do is some t-tests. So I'm going to use the t.test function that we've already talked about in the introductory portion of this workshop. I can supply a data argument for t.test, but also I can remember that data.ok is currently attached. So I can refer to variables contained within it by name directly without reminding R to look in data.ok. The search function just shows me the search path in order that R will try things as another reminder. So some simple t-tests. I'm going to call t.test of this formula. Discrim is legal on the basis of condition with the assumption that the variances are equal. So this will be a conventional student's t-test. And these are the two means that we've already seen a bunch of times, right? 5 in the legal condition and 2.5 in the illegal condition. They're pretty far apart as Likert scales go. So it will not come as a huge surprise that this difference is highly statistically significant, no matter how you choose to conceptualize the statistical question. We could relax the assumption about equality of variances. We could do all sorts of other things, do a rank test. It doesn't matter in this case to the overall conclusion. But again, that's just a manipulation check, so not that interesting. So I could do a few other t-tests. This is the claim that the participant believes that most people support discrimination. Seems to be a bit higher in the condition where they're told that discrimination is legal. And so that's consistent with the possibility that our participants are using the law, specifically the judicial system, as one piece of information about what they think their fellow citizens believe about sort of moral or proper behavior, which is like one of the theories that we're trying to test in this study. Here's the same thing for the participants' own support for discrimination on the basis of mental illness, so appears to be higher in the legal condition as well. Their evaluation of Amy as a person, the person who brought up the lawsuit that they read about, does not appear to differ by conditions very much. We already knew that. The means are very close. The standard deviations are much higher. So this formal t-test doesn't really contribute much there, except to say, indeed, we lack evidence to claim that this slight empirical difference is distinguishable from chance. And the same for this standardized evaluation measure. Other useful statistical tests include comparisons of variances. So I'll show you the var.test function built into R. So here the formula, again, is I support discrim by condition. And this test will just compare the variances of each of the conditions. The ratio of variances is 0.8. The p-value is 0.3 for this f-test, so not strong evidence to claim that that ratio is lower than 1 by a margin big enough that we would expect it to only rarely come up due to chance. And you may not have seen this kind of test before because it's not often taught in basic stats classes, but it is just a simple f-test. An f-test always is a ratio of two variances. So when we do it for an ANOVA, we're looking at the ratio of the variance explained by some term in our model to the error variance in the model, but it's still a ratio of variances. And so it's perfectly fine to also look at the ratio of variances that are present in different subsets of the sample when doing this kind of f-test. It's maybe not the best way to compare variances across conditions, but it is one way to do it. A more common way, though, is Levine's test. And so here is that. And here we get some information about a comparison of variances when we're using the median as the center. So that function is just Levine test with a capital T, and the other one was just var.test.